So how do you put this triangle?
You connect these two share the side, if bisects will work. So that's a yes. You don't know that anywhere.
It's a right. Oh, it's a right triangle just because of this. Because we draw.
I'll say lights all the time.
I don't think it's a right triangle.
Right. You're right. It's an isosceles triangle.
But this one.
It forms two right triangles. Which form an isosceles. That's how. Like these two are right triangles. This is an isosceles. It goes back and forth. This line over here is the line that exists between these 2 points. And so if you draw any point on this line and you connect these two, you're going to have an isosceles triangle. That's what the definition of the line is equidistant. At this point, equidistant to that point, that point.
You can make the proof kind of informal to make sure that you get all questions like that. We're just going to kind of just assume.
Okay, wow. So,
That's right. Yeah, make two more points for your parabolas. Okay, 2 more minutes. Be sure to get a few more points on your parabola.
we can just set that. Except there's no like formal geometric theorem that says like control sheet, whatever. I don't think it's like if we had to actually do it, even though they didn't want us to, like, if we had to actually do it, we could have done it. We would have been able to do it like putting all these, congruent triangles corresponding points. That's 9 points now. So 1, 2, 3.
Okay, everyone, let's stop for a minute and let me direct your attention to the front. First, this one was a good one. Here's Ida's. She's got 10 points. And hopefully yours, you did verify that yours is looking very much like a parabola. But making the parabola is okay, but understanding why that is a parabola, that's the hard part. So let's go through some of the answers to these questions. And if you take a look up at the screen, and let's have everyone stop for a minute, and Jennifer, Leanne, you hit the lights. Up on the screen, I have this program, which you actually have built into your calculator. And this is the situation that you've had. This here is F. This is R1. This is the point. This line here is the crease. Now, what is that crease? Let's go for a volunteer first. What is that? Yeah, say that. That's exactly right. Now, if someone had asked, how do we know that for sure? And that's something we're just going to kind of assume, because to do a formal proof would be tricky. But for now, it seems like it is the perpendicular bisector, and it is. It definitely is the midpoint. Now, what is it about this triangle? And by making this on this program, take a look at what I'm able to do. I can actually move to this point and I can move it around and see what happens. So basically, by moving this point around, the crease, you can see the crease changing, and you can see the intersection point, meaning also, what's so special about the triangle? Volunteers for that? Special about the triangles? Okay, go Daniel. How can, now, this is a big part of the proof. How do you know it's isosceles? I'll give someone else a chance to justify that. Robin?
All the points on the perpendicular bisector are equidistant from the 2 points on the base, and so the sides have to be isosceles, because you have congruent right triangles, and since they're congruent right triangles, corresponding parts of congruent triangles are congruent, so you know the two legs of the triangles.
Oh, great point. You actually explained it both ways. Some people did an actual proof of the isosceles triangle, prove that they are congruent triangles. But you mentioned at the end, and say Jal mentioned in her group, that you don't even need to prove the triangle's congruent. The sector right there says all points on the perpendicular bisector are equidistant. So either of those are okay. So take a look at this. As we move it around, you can see this point over here, this intersection point, which is what you've been calling S1, S2, S3, and all that. I also have here listed the actual measurement of those lengths. And you can see that they're equal. I don't know what happened there, 3.0, 3.1. That's a little glitch, I guess. Anyway, you can see that point moving around and making the parabola. So what is the locus definition then? Anyone have a nice official locus definition for this? And Jennifer will have the lights for a second again. And let's get this one down onto the paper. An official locus definition. This is sort of the final step of this. Okay, let's go with David. And everyone, let's write this down.
A parabola is the locus of all points that are equidistant from a point in a line.
Unlike a circle, we don't have to be given a specific distance. It's just all the points that are equidistant from a point and a line. And that's why this thing makes the parabola. And Jennifer, if you hit the lights one last time, I'll show you something pretty neat on this. This Capri Junior program, which you have, some people were issued it as a Geometry Sketchpad program. One thing you can do with this is you can hide some of the lines. I just want to show you what that looks like when I hide a few of these lines. I hide this guy. I'll hide this. Hide this. Just going to hide the crease. Hide that, and finally I'll hide this perpendicular line. And this line segment. There. So now that everything's all hidden, now I can pick up this point here and just move it around. We can just watch that intersection point is still there. So even though all those lines are gone, the intersection point is still there. So I can kind of move it around. You can see this thing moving around the parabola. And another thing I could do that's kind of neat is I could actually move the focus point and watch how that affects. If I move it, let's say I move it up. So now I'm able to conduct this experiment again with the focus a little further from the line. Take a look at what happens now. I end up with a more sort of flattened out parabola. So are there any questions about locus definition of a parabola? Let's do two things. We're going to turn in the work that you did today. But first, move your desks back, then organize your papers. you have a minute or two.